Do you have any idea how the tiny lights in your devices work? This question leads us to our topic today: light-emitting diodes, or more commonly known as LEDs. These minuscule yet mighty components are integral to the technology we use daily. From the screens of our smartphones and televisions to the headlights of our cars, and even the humble indicator lights on our appliances, LEDs are everywhere. They may seem insignificant, but understanding how they work can give us a deeper appreciation for the technology that surrounds us. This knowledge can also empower us to make more informed decisions when it comes to purchasing electronics and optimizing their use. So, whether you're a tech enthusiast keen on understanding the inner workings of your gadgets, or just someone curious about the world around you, this exploration into the realm of LEDs is for you. Stay tuned as we dive into the fascinating world of light-emitting diodes. To understand LEDs, we must first understand a bit about electricity and light. Let's start with electricity. Simply put, it's the flow of electric charge. This charge is often carried by free electrons moving from one place to another. This flow, known as current, is what powers our devices. Now, on to light. Light is a form of energy known as electromagnetic radiation. It's made up of tiny particles called photons, which travel in waves. These waves have different lengths, and the length of a wave determines the light's color. The shorter the wavelength, the bluer the light. The longer the wavelength, the redder the light. Here's where it gets interesting. When an electric current passes through certain materials, they can emit light. This phenomenon is known as electroluminescence. And this, my friends, is the basic principle behind LEDs, or light-emitting diodes. A diode is a type of electrical component with two terminals. It's a simple semiconductor, meaning it can conduct electricity under certain conditions. Semiconductors are unique because they can be either conductors or insulators. This ability to switch between conducting and insulating is what makes semiconductors so valuable in electronics. In the case of an LED, the semiconductor material is specially prepared to allow for electroluminescence. When current is applied to the diode, the electrons in the semiconductor material are excited to a higher energy level. As the electrons fall back to their normal state, they release energy in the form of light. The color of the light depends on the semiconductor material used and the energy gap the electron falls through. So, we've seen that LEDs are more than just a pretty light. They're a clever application of principles from both physics and electronics. They take the electricity that we're all familiar with and turn it into light through a process called electroluminescence. Now that we have a basic understanding of electricity and light, we can dive into the workings of LEDs. LEDs, or light-emitting diodes, are a type of diode that emits light when an electric current passes through it. But what's going on under the hood, so to speak? What makes these tiny beacons of light tick? Well, let's start with the structure of an LED. Picture a sandwich, but instead of bread and cheese, we're dealing with semiconductors. The bread layers are made of N-type and P-type semiconductors, each with a different role. The N-type semiconductor has an abundance of free electrons, while the P-type has what we call holes, or places where an electron could potentially reside. The cheese in the middle is the depletion region, a zone where the free electrons from the N-type semiconductor meet the holes from the P-type, creating a sort of no man's land. Now, when we apply an electric current to this semiconductor sandwich, things start to get interesting. The current pushes electrons from the N-type layer towards the P-type layer. When these electrons meet the holes in the P-type layer, they fall in. This process is called recombination, and it's where the magic happens. When an electron falls into a hole, it moves from a higher energy level to a lower one. This drop in energy has to go somewhere, and in an LED, it's released in the form of light. The color of this light is determined by the exact amount of energy that's released, which is why LEDs can come in so many different colors. So, in a nutshell, an LED works by pushing electrons through a semiconductor structure, causing them to recombine with holes and emit light. It's a perfect example of how we can harness the principles of physics to create something as practical and beautiful as a source of light. That's the basic principle behind how LEDs emit light. But what makes them different from other light sources? LEDs have several advantages over other light sources, making them a popular choice in various applications. Let's dive into the details. Firstly, they are energy efficient. Traditional light sources like incandescent and fluorescent bulbs waste a lot of energy by emitting heat. LEDs, on the other hand, convert almost all their energy into light, making them significantly more efficient. This efficiency translates into lower electricity bills and a reduced environmental impact. Secondly, LEDs are long-lasting. They don't burn out or fail like other types of lighting. Instead, they emit less light over time, a process called lumen depreciation. This means that an LED light can last up to 25 times longer than its incandescent counterparts. That's a lifespan of more than 25,000 hours. The compact size of LEDs is another advantage. They are small and can be used individually or as part of an array, making them incredibly versatile. This compactness allows them to be used in a wide range of applications, from tiny indicator lights on electronic devices to large digital billboards. Then there's the robustness. LEDs are solid-state lights. This means they are made of solid material with no filament or tube or bulb to break. This makes them much more durable and less prone to damage than other types of lights. Additionally, LEDs offer brighter, more vibrant colors. This is because they emit light of a specific color, which does not require any color filters like other light sources. This makes them ideal for displays and signs. Lastly, LEDs are safer. They operate at a much cooler temperature than incandescent bulbs, reducing the risk of burns and fires. So to sum it up, the advantages of LEDs include their energy efficiency, longevity, compact size, robustness, color quality, and safety. With these benefits, it's no wonder LEDs are found in so many of our devices today. From your smartphone screen to traffic lights, LEDs are everywhere. And that's no exaggeration. Light-emitting diodes, commonly known as LEDs, have a wide range of applications and have revolutionized lighting and displays across various industries. Let's start with the most common application of LEDs: lighting. From homes and offices to streets and stadiums, LEDs have replaced traditional light sources with their energy efficiency and longevity. They've even made their way into our pockets, with flashlights on our smartphones and other portable devices. Next, let's take a trip to Times Square or Piccadilly Circus. Those huge, bright billboards you see, all powered by LEDs. Known as LED displays, they offer vibrant colors and high brightness levels, making them ideal for outdoor advertising and information boards. Inside, you'll find them in televisions, computer monitors, and yes, your smartphone screens. From big to small, LEDs have taken over the display industry, but it's not just about lights and displays. LEDs have important roles in other areas too. They're used in traffic signals and car headlights, providing better visibility and safety. In the medical field, they're used in various devices like pulse oximeters and phototherapy units. Even in agriculture, LEDs are used in indoor farming to provide the right light spectrum for plant growth. And let's not forget about their role in technology. From data transmission in fiber optic cables to status indicators in electronic devices, LEDs have become an integral part of our tech-driven lives. The applications of LEDs are vast and continually growing, thanks to their versatility, efficiency, and durability. They've changed the way we light up our homes, how we advertise, the way we grow our food, and even how we transmit data. From tiny indicator lights to massive outdoor displays, LEDs have truly infiltrated every aspect of our lives. The versatile LED has truly transformed the way we see and interact with the world. Whether it's lighting up a room or displaying information, LEDs have become a fundamental part of our everyday lives. The LED revolution is here, and it's here to stay. So that's how the tiny lights in your devices work. Quite fascinating, isn't it? We've journeyed together from understanding the rudimentary elements of electricity and light to unraveling the intricate functioning of light-emitting diodes, or as we all fondly know them, LEDs. We've discovered how these tiny, luminous wonders are power-efficient, lasting longer than their conventional counterparts. They're not just about illumination, but also about sustainability. We've also explored the myriad applications of LEDs, lighting up our screens, our homes, and even our cities. We've seen how LEDs have revolutionized technology, from digital displays to remote controls, and from traffic signals to medical devices. They're tiny, but mighty, playing an integral role in our daily lives. Next time you see a tiny light, remember, there's a lot more going on than meets the eye. Thank you for joining us on this enlightening journey into the world of LEDs.